Okay, in this chapter, we're going to look at methods for testing nonlinear model restrictions. And this general approach that I'm going to describe is also called the delta method. Okay, so in the previous chapter, in chapter 5, we did tests that are linear combinations of model coefficients, like beta 1 equal beta 2, or beta 2 equal 2 beta 3, or beta 3 equal 4. Those are all linear restrictions. But suppose we want to test a hypothesis, which is some general function of the regression coefficients. Like we want to test this function of the betas equals 0. All right, so you can kind of adapt the other framework we had by approximating the nonlinear function. So here, this f of beta is this function. And we can take what's called a Taylor approximation. So you probably did this in a math class, like maybe a calculus class. You Taylor expand the function around the true beta. So beta without a hat is the true beta, plus this derivative, and then this is beta hat minus beta, okay? And this derivative is evaluated at a point beta star, where beta star is in between beta hat and beta, okay? So because beta is consistent, all of these things, so beta star is going to beta, and beta hat is also going to beta. Okay, so notice under the null hypothesis, f of beta naught equals 0, because this is our f of beta naught. So you probably did this, you may not remember it, because I think it's called a mean value theorem, which you would see probably in your first calculus course. Think back, try and dig it out of memory. You probably did this at some point, these types of Taylor expansions. Okay, so let's just look at an example. So if this is my f of beta, then when I take the derivative with respect to beta 1 is this. The derivative with respect to beta 2 is this, right? Because we take the derivative of what's inside, so you pick up another 2. Right, I'm going to define this as gamma. Okay, this prime actually is going to be defined as gamma. Okay, under the null hypothesis, so remember the null hypothesis, looking back, is that f of beta, f of the true beta equals 0. So in that case, f of beta hat is equal to this derivative times beta hat minus beta. Okay. All right, and so we know the distribution of this object here. And so what we basically have is like a quadratic form. We have, remember before I had a notation like AV or whatever, but this is like that. So we have this gamma, times something that's normally distributed. So the overall distribution is going to be normal, mean 0, and this is the variance-covariance matrix. Okay, and you can set it up as a wall test. Okay, now once we know the distribution, we can set it up as a wall test. I mean, in this case, you could also do a normal test. If you just have, one hypothesis, so it's one restriction. So this is actually, even though they're two betas, this is going to be like 1 by 2, 2 by 2, 2 by 1. So this is actually 1 by 1. So you could do a normal test, or you could do a chi-square test. So you have the option of doing either one. All right, and this would be the chi-square test. And notice I need to get, like here, this gamma depended on beta star. And of course, beta star is unknown, right? But what we're going to do is in estimating the gamma, we're just going to put in beta hat. Since they're all consistent, as beta hat is going to beta, beta star is going to beta, so we can estimate the gamma by just plugging in beta hat. That's what's done here. And also the sigma, we just plug in beta hat. All right, and so that's how you would test this hypothesis. All right, here I said we estimate the variance covariance matrix by substituting beta hat for beta and beta star. This should be a superscript. Okay, I think this is the last slide. Yeah, this chapter is kind of short, but so I would suggest just trying to set up the test for a different function. I think if you look in the back of the chapter, some of the exercises, it gives you some different functions. You can just try to verify that you can set up the tests. And you could actually do multiple, like if you had multiple nonlinear tests, you could do that. Then gamma would actually be a matrix instead of a vector. I just didn't include any examples like that because it gets, it's kind of unusual to have to do that. But in principle, you could do that if you want. All right, so that's it for this chapter. So short. Oh, I should mention the delta method. It's a very useful method. It's actually used in a lot of econometrics, deriving out distributions, because sometimes estimators are functions of other estimators. So it's not only used in this context, it's just like a general technique that people use to get the asymptotic theory for a variety of estimators.